Hi, and welcome back. When speaking a foreign language, or even our native language, we sometimes make mistakes. While coding, the situation is no different. What's great about programming is that you get notified about your mistake. Python, like any other programming language, will display an error message when you request it to do something it does not understand. Consider the following Jupyter Notebook document. Disregard the syntax we'll use and focus on the operations conceptually. They will be a mix of mathematical and programming requests. To begin, we will execute this cell to specify that we'd like x to be equal to the sum of 5 and 3, that is 8. Then we'd like Python to display the value of x for us by running print x in the following way. In the output field, we see what we expected, the value of 8. This means that we have worked correctly and have abided by Python's syntax. But what happens when we do the opposite and disregard the Python rules? As we request the value of y to be displayed, we obtain an error message. How come? The reasons can be many, but what is sure is that we have asked Jupyter to do something it cannot understand. To solve this problem, Jupyter itself assists us by explaining to the best of its abilities what prevents it from executing the operation from the relevant code cell. Please remember, and this is extremely important, the idea is to use this hint to improve our code so that we obtain the desired output. In this example, we are having a name error. Jupyter is even being specific by telling us it doesn't understand what we mean by y. Here is the moment where you, as a programmer, have to realize what type of an error that is. Considering that the interpreter is reading your code letter by letter and line by line, this means that there was nothing wrong with what we've written until y. So, the error seems to be related to that letter, and the last line of the error message confirms it. Please remember that in the majority of times, the last line of the error message indicates where the problem is coming from. Then, as programmers, we realize we can solve this particular problem in two ways. One would be to provide a value for y. The other is to assume that we have just not referred to the correct variable. Therefore, we can substitute y with x and execute the cell again to obtain a satisfactory output. Great! It doesn't sound hard at all, right? Well, yes, but that's just the beginning. It is important to realize there's no guarantee that you are having a single cause for a problem. For example, if you type print y like this, Jupyter will just indicate that it doesn't understand what the first 4 letters are there for. It will be the job of the coder to remember that the command they need is print, not prit. At the end of the day, you may have just made a typo. However, when you correct this and re-execute the code, you'll receive an error message again. At least, this one looks familiar. You know how to solve it within the boundaries of our example. So, substituting y with x can finally lead to the right outcome. All right. Aside from the technical perspective, there are several takeaways from this lecture. We can't rely on Jupyter to be always telling us the exact reason why it was not able to execute or request at a specific moment. It is amazing how accurate and precise it can be in its suggestions. But don't be surprised. Sometimes the obtained error messages won't be very clear to us, the programmers. Therefore, it will be our job to understand the messages and decide on how to solve the given problem. Then, don't forget that coding is all about using a programming language to solve certain analytical tasks. So, every programmer has encountered countless error messages on their way. What is important is to know how to handle them. Try to understand and resolve them, and don't pretend you're able to write the perfect code from the first try. That is impossible. On that note, please follow this guideline. Don't quit on your task, and be ready to respond to as many errors as you need. Of course, this doesn't mean there's no place to get support from. For instance, you can Google the error. Just paste the last row of an error message online and see if there's a thread or a post that can help you solve the problem yourself. This approach will not be preferred or needed throughout the course, I believe, but will serve you a great deal after completing it, or also as a professional when you will already be an independent programmer. In other words, Googling the error is what you would do on the job, so it is good to get used to it. Regardless of whether this strategy works, you can search for the relevant error in the Q&A forum. Alternatively, if you can't find an answer there or you stumble upon a recurring problem, please do feel free to post a question yourself. We will be happy to reply as soon as we can. Just when you do that, please stick to the following structure. Let us know what your task is and what output you're aiming for. If you can point us to a particular lecture or section from the course, please do that as well. Then, paste the exact code you have executed before obtaining an error message. Third, provide a screenshot of the error message, or at least its very last line. That one is very important. Finally, anything else you can share about the problem will be much appreciated. Having this type of information will help us immensely to assist you better. So, we would be extremely grateful if you spend the time to provide it. To conclude, you don't need to just try and execute random code at this stage, but the principles delineated in this lecture will be applicable while programming in Python or other languages throughout the entire course and beyond. This will do for now. Thanks for watching.